Right. So far we have seen that order and degree, and also the given function is a solution or not. Now third exercise, how it is formation of differential equations. Formation of differential equations. Here only one general solution will be given. From that we are supposed to find the equation how it will be. Right. Here while forming the equation, one term will take major role. The terms are called as arbitrary constants. See how many arbitrary constants are there, that will decide the order of the differential equation. Right? Okay. Now see that one. If the given function, if it is f of x comma y comma c1 comma c2 comma cn, so anyhow we are differentiating with respect to x n times. So while doing that one here, because c1 c2 c3 and cn, there are n equation with n arbitrary constants, right? So then what you could say, we will get the equation as a differential equation, the order which is n. So what I am trying to say here, n arbitrary constants are there. If you do that, whatever the methods like elimination method, like step by step, if you do that, finally you will get the equation which is satisfying by this function. That function order is, that equation order is n. Correct? Now, for example, y is equal to mx. Y is equal to mx. Here, m is one arbitrary constant. So, if you do the process of differentiation, then the equation order will be 1. Now, y is equal to a sin x plus b cos x. Here, he said clearly a comma b are two arbitrary constants. So, the order of the differential equation will be 2. And next, c is equal to y into c plus y whole square plus x cube. Here, arbitrary constant is set as c. So, we can do that equation, whose the order of the differential equation is 1. Okay, now one more question. This question often they are asking, like IIT, any competitive based exams. Now y is equal to c1 plus c2 into cos of x plus c3 and c4 into e power x plus c5, where c1, c2, c3, c4, c5 are 5 arbitrary constants. Now what is the order? Say generally what we learned it so far n arbitrary constants. So the order of the differential equation will be n. Here one arbitrary constant 1, 2, 2. Here 1, 1. Fine. Now here find, generally people will write 5. This is wrong. So order of the differential equation is 5. This is wrong. Now y is, see, let me brief you. See, y is equal to, is said c1 plus c2. c1 plus c2, it is, we can write one constant together because c1 plus c2 is a constant, and cos of x plus c3 minus, then what you can write it, c4 into e power x into e power c5, then if you simplify, y is equal to c into cos of x plus c3 minus c4 and e power c5. E power c5 also one constant. This also one constant. So constant and constant, again constant. So I am taking another constant, e power x. Now if you see how many constants are there, arbitrary constant. These are all independent arbitrary constant. So remember, the order of the differential equation could be defined by the number of independent arbitrary constant. So 1, 2, 3. So order will be 3. So at first starting we have written 5. Now it is 3. So what I can say, 5 is wrong. So this is a way you have to find the order of the differential equation. Let us solve some more problems on this. Right. This is exercise 9.3, example 4. Form the differential equation representing the family of curves y is equal to mx, where m is an arbitrary constant. Okay, fine. Now, here y is equal to mx is a given equation or general solution. Now y is equal to mx. So now you take that y is equal to mx. Now if you see, according to the solution, according to the question, how many arbitrary constants present? One arbitrary constant. So now what we are supposed to do? Differentiating differentiating on both sides with respect to x, we get, with respect to x we get it. Now differentiating, so it becomes dy by dx is equal to m into, for x it is 1, so what I can say, m is equal to dy by dx. This is number 2 and this is number 1. Okay, substitute equation 2 in equation 1, or substitute m value in equation 1. We get, what you get in, m is equal to dy by dx. So y is equal to, what I can write it, y is equal to dy by dx into x. So I can write simply y is equal to x y dash. X y dash minus y is equal to 0. Okay. See, in the final solution there is no arbitrary constant. So I can say one word, eliminating arbitrary constants. So we learned in 10th standard, right? Eliminating theta in trigonometry. Same way, eliminating arbitrary constant. Ensure in the final answer there should not be any arbitrary constant. This completes the solution. Right. Now one more question on the board, if you are seeing that one, it is example 6 from the exercise 9.3. Form the differential equation representing the family of ellipses having foci on x-axis and the center at the origin. This is also simple. Now what is trying to say? The foci on x-axis and center is the origin. So roughly we can take the diagram. See, the equation of the ellipses will be like this. The equation of ellipses will be like this. Okay, the general equation which we learned in the 11th standard, the general equation will be, general equation is, what is that? X square by a square plus y square by b square is equal to 1. X square by a square plus y square by b square equal to 1. If you see here, what are the arbitrary constants? Here, two arbitrary constants are there. What are that? A and b are two arbitrary constants. Two arbitrary constants. Now what I am supposed to do? Differentiating on both sides with respect to x we get. Okay, now for x 1 by a square, it is a constant, it will become out x square, it is 2x plus 1 by b square as usual, and for y square it is 2y y dash, because for y square 2y again y dash is equal to 0. Now what I am trying to do, 2 I will take out common, I will send it 0 by 2, it is 0. So now I will get it x by a square plus y dash by b square is equal to 0. I got it now. Okay. See, I said actually two arbitrary constants, so we have to do 2 times differentiation. So one time we did. Again we have to do, again differentiating on both sides with respect to x we get. On both sides with respect to x we get. Okay, now again, so if you do like as usual, what happens, x by a square y by dash by b square, the question may be you confusing. So what I am doing, I have written again differentiating on both sides with respect to x. Say, but what I am going to do, I am going to simplify this one. How I am going to simplify? Look, y dash by b square is equal to minus x by a square. Now y dash by x is equal to minus b square by a square. Right? If you do the differentiation, this one, see, this side only xy terms you have, this side constant. So when you are doing the differentiation, this becomes 0. So instead of going blindly, now you have to take some steps for this, like simplification, how to eliminate AB. Okay, fine. Now if you do, this is what happens. Again, if you are doing the differentiation, it becomes u by v. So what is the formula for u by v? Differentiation, it is v square v u dash minus u v dash. So same thing if you try x whole square v x into y dash whole dash minus y dash into x dash is equal to 0. Okay, fine. See, why it is 0 you understood, because differentiating on the next side, second side also it turns as 0. Now see, again if you see here, again it is UV method. So UV method, what is that? UV whole dash, which is u dash v plus vu dash. If you apply that one, what happens? X into y dash whole dash. This is u and this is v. So y dash whole dash plus y dash into y dash, u v dash plus v u dash. Okay, fine. Almost solutions completed. Minus y dash for x dash is 1 is equal to 0, because what I am doing, this x square also I am sending 0 into x square. Then x into y double dash plus y dash whole square minus y dash is equal to 0. Now simplify. So what you are going to get it? Xy y double dash plus x y dash square minus y dash is equal to 0. So did you understand? So what is the general equation we have taken? X square by a square plus y square by b square equal to 1. There are two arbitrary constants a and b. So eliminating differentiating 2 times, I got the equation at finally y double dash plus y dash whole square minus y dash. If you see that the highest order will be y double dash. Highest order y double dash. So order of this equation is 2. So highest term is y double dash. So order of this differential equation